Everyone, welcome to part 2 of learning opencv. And now in this session, first topic I'm going to take is how to create track bars on an image. And let's say we want to change the values of the red green, that is the RGB values of that particular. So first, what we are going to do is we are going to import the libraries, that is the numpy. I need numpy to create an image, and opencv 2 library, which we are going to do import. Okay, next let's create a black color image using numpy. So let me get in comments creating black image using numpy. So let me just keep the name img np dot zeros is the function which I'm going to use, and I'm going to say uh, like a first value I'm going to give is the size of the image. So let me say 300 by 512, and it has to be in 3 dimensions, three channels, that is the red, green, and okay. And now the data type, it's going to be unsigned integer value, which takes like 8 bytes of memory. Give it as 8. Now this is how you are going to create a black image. Okay, now what I'm going to do, since I have to show this image on the screen, so I will put it in a while condition saying that while true. So for true it is 1, and here I'm going to say while it is true, cv2 dot im show that particular image. Okay, but as you know that we have to name the display window of that particular image in which it is showing. So simply let me keep it as a image itself. So it is going to show my particular image, which the variable we have kept it as img. And now I'll put a key value like this, saying that if key value cv2 dot wait key, okay, if it is 1, and then I'll add the and statement. I'll and statement say first you have to say 0 x ff. This is the code like this. Okay, you have to use this one and say like this, like if the key pressed by the user is equal to the escape button, key value is like 27, then only you break the program, and in the next line we are going to say destroy all windows. So see, we're going to call the destroy all windows method, and it's going to destroy the image itself. Okay, so let me just run this one, and as you can see we are getting a black color image on the screen. So the basic coding how to create an image using the numpys all zero. Okay, now coming to how to create a tag bar. So let me come up here, write it in comments. So creating tag bar for the image. So this is done by using cv2's function that is called as create tag bar. So let me use this one. Okay, now just before using this function, what I'm going to do is I'm going to use cv2 dot, okay, there is something, there is a new function called as named window. Okay, so this is used to keep a name for your particular window. Okay, so let me just keep the same name which I have chosen here as the image. Okay, so you can use this named window also to do the exact same thing. Okay, now what I'm going to do in this create track bar function is the first argument I'm going to keep it as the blue channel, which we are going to change for this particular image window, that is called as the image. So that is going to be the second argument, and the value will start from 0 to 255. Okay, I know the color ranges from 0 to 255, so I'm going to keep that one. And now I'm going to call a callback function over here, okay, which will get me the position of x value where we are changing the color. Okay, you can name anything. So simply let me keep the value as or the function name as nothing. Okay, this function I will be creating just to get the value of x. So x will be the starting point. So let me define that function called as nothing, and it takes the value x inside it, and it will print the x value on the screen. So this function gets called every single time. Change the position of the track bar from 0 to 255. for the blue channel. So just like this, I'm going to copy and paste it for the other two channels as well, and say this one is for green, this one is for red. Okay, and every single time, whenever we make some changes from 0 to 255, nothing callback function gets called automatically, and it will give you the position of the X where it has been being changed. So let me just right click and run program once again. As you can see, I've got the three track bars over here, and its range is from 0 to 255. So if I just increase, okay, as you can see now we are at 16. So it is saying we have moved that many points. That is because of this nothing function which we have just created, which gives the location, okay, location of the track bar where it is exactly. Okay, then let's come for the green channel like this. Okay, so green channel we have set it for 45, 44, then red one till 78. This is how you can get the values of this particular variable X whenever you change the values from 0 to 255. Either it might be blue, green, or red channel. Now let me get rid of that. Now next operation what I'm going to do is, okay, I'm going to get these values, okay, that 78, that 44, and all those things, okay, as variables, and I'll store it here, here in this if condition. Okay, just after the if condition, so I'll say b value is this much, which my cv2 will get track bar position. Okay, there is a function called as get track bar, okay, pos, that is the position. Okay, and position I want is for the blue channel, so I'll keep it as b here, and it's from this particular window which we have named it as image. Okay, and just like this we want to get the position of the other two channels, that is the green and red. So let me just, and here also let's make this as capital B. Here bottom I'm going to R, the left side as well I'm going to change this to R. Now these are the values which we want to show on that particular black color image, so that it changes color accordingly. Now to set the value of this blue, green, and red on the particular image, you just have to say image, okay, and then you just have to put a colon symbol, which means from the starting channel to all the channels, okay, you're going to set these three colors for all the three channels, that is the blue, comma, green, comma, red. So these are going to be the color values for this particular image. Come here, let's run the code. Okay, now let me just make this blue color, and as you can see the image color is changing to blue color. Okay, and just like this let me just make this as green color by moving the track bar on the green color like this, and finally the red color. So this is how you can change, okay, the background color for this particular image which we have just created, just by getting the values of blue, green, and red in the track bar and setting that particular color of your particular image. Now let me hit escape, and that program will terminate. Okay. Now the next part of the code I want to teach you about is hue. For that, first let me just create a new Python file called as e, and we are going to be using just like RGB. So let me just write here in comments, just like RGB. Okay, we can use the hue values. Let me show you what are those. So let's just, here we have an hue. Okay, so hue stands for like HSV, so hue, saturation, and values. Okay, hue is nothing but it is the range of colors which we use, and saturation is nothing but from the grayscale to the brightness of that particular color, whichever we are going to from the H scale. Okay, then the last value, the value will be from 0 to 1. Okay, so 1 defines the brightness of that particular color to be the maximum at 100%. So 0 will be at 0%. From 0 to 100, the value of brightness will increase. Saturation increases the grayscale. Okay, So 0 means it will be like a black and white, and it will be 1 means it will be the highest point of that particular color, and hue will be the color which we are going to select from this particular these three values. Okay, so first we are going to use some kind of a coding to identify some kind of a color or object from that particular image, just like RGB. We are going to use HSV values. Okay, so let me just very quickly import CB2 library, and let me say import compile as np, and I'm going to define a callback function as nothing, and it will get me the value of variable x. Okay, then let's name that window, named window, let me say tracking. Okay, this time we'll be tracking some part of the image or an object from the work from that particular image. So I'll say while true. Let's come to the next line. Okay, we have to use the CV2 library to read the function, a read function, and we have to read one particular image. Go to our image folder. Let's select some folder. Oh, not folder. Let's look out for an image we have to work with. So let's select this particular image. Okay, so let me just go to open with Explorer option, and it will, as well as that particular file. What you can do is you can on the properties, and here you'll get the full path that particular image. Or what you can do is you can also copy it from here itself and write down that image name over there. So let's just click image and do the path over here forward slash, and now we'll just have to write smarties.png, smarties.png, but don't forget to make all the backward slash into forward slash. So let's here and those. So this code will successfully read our image, and let's keep it as a frame. So let me just say like this: frame is equal to CV2 is reading that particular image. Now in the next line we are going to show that particular image. So let me make this as cv2 dot im to function I'm going to use to show this frame which we are seeing on the screen. Okay, and I will also name that window as frame itself on the left side. So this is how you are going to read, and this is how you are going to see the image on the screen or show the image. Okay, and now I'm going to say cv2. I'm going to keep a key to wait for at least one. Okay, this will be the code, and I will say if the key is equal to 27, then only quit or break my program. No need to go any further. And cv2 dot destroy all windows is the function. Finally close the program. So just save it, and let's very quickly run the hue program which we have created. So we are successfully reading the image from this particular folder that is called as smarties.png, and we are showing it on the screen using the imshow function. Now if I click on the escape button, the program is going to get terminated. So let me run the code once again. And now in this project, what we are going to do is we are going to track either all the blue color balls or green ones or the red ones based on the hue, that is the saturation scales which we are going to select, and we are going to track only those particular objects depending upon these three colors. Okay, so let's do that for this project. So this is the entire code right now. First of all, what you have to do is you have to convert your blue, green, and red scales to into the HSV values. So that can be done using code. So let me put it here. HSV is equal to, I'm going to name it as HSV itself. So from CV2 library, if we have to change the color, you have a function called as CVT color. Okay, in this one you have to mention which image color you are trying to change. So this is the image. which we have kept it as frame, and this color, okay, from CV2 I'm going to use the color color. You have to write it in capital underscore. There is a function called as blue green red to HSV, this one. So the blue channel, green channel and the red channel will get converted to the HSV values. So let me use that particular function. Okay, now the next step, okay, next step is to find or you have to create that particular blue color in as reference to which you are finding to track that particular image. Now what will be the next step means, okay, I will define a lower blue color, okay, and the higher blue color, the maximum higher blue color what we can get from that particular image. Okay, and by just by trial and error method, okay, I have tried out this array. I've created an array with these three channel values for red, green and blue. So in order to get a blue color, very lightish blue color, so those numbers are like this: 110 comma 50 comma 50. You can also try this with trial and error methods. So I have tried it. So for the upper value, okay, it's going to be very closer to what's the 255 scale. So let me just come up here and as a list we have to give 3. So trial and error method I'm using. So I figured it out that lower blue value and the higher blue value will be in these three channel ranges. Okay, now this will be the mask which we are going to apply on the HSV image which we have just converted of that particular frame. So simply let me make it this as mask is equal to CV2 dot, okay, I'm going to use a function called as in range. There is a function called as in range in which you will have to pass the image, that is the HSV which we are trying to convert. Okay, and we have to get from the lower blue value to the higher blue value. So this is how we are going to make a mask which we are going to apply on that particular image. Okay, now the next variable. Now in order to apply this mask on that particular image, what I'll do is I'll create a variable called as result is equal to, okay, I'm going to use a function called as bitwise and operator. Okay, so it wants a source 1 and source 2, that is the our source 1 is the frame, okay, that is our colored image. So let me just pass on that, and source 2 is also that same particular image itself on which we are trying to put this mask on, that this is the mask of blue color balls which we are trying to get. So I'll say mask is equal to, this is the mask variable which we have just created over here. Okay, and then what we will do, since we are showing our original image on the screen, just like that, let us show the mask variable as well as the result variable. So let me just copy this and paste it over here, and here let me just make this as mask. The displaying window also I'll keep it as the mask itself. Here final the result variable, that also, and result, okay, like this. So now let me save it and let's run the program. If I run this program, okay, we are going to get three windows like this, three windows. Okay, so let me show, come here and here. Okay, see this tracking window is for the code which we have written here at the top. Let me just show you. This is the tracking window. Okay, now let me go back and show all the windows to you. Okay, see guys, here we have put the mask on the blue color window, okay, the blue color balls. Okay, so we are getting, this is the mask window, okay, this is the result window, and this is the original colored image window, and we have one more, the tracking window of that particular object. Okay, so this is how this code is going to run. So now what I'll do is I will create one track bar so that, okay, we can manually set different colors. So right now it is set only for this blue color. So, and it is like hard coded text. But if I have a track bar which I can set it from 0 to 255, so automatically it will track the other object colors itself. So for that we will need this particular window, the tracking window. Okay, and you will have to select or create a track bar to set the lower hue value, the lower saturation value, and the lower L value. Similarly, the upper H value, upper S value, and the upper V value from this particular image as I was showing you. So this will be the lower saturation, this is a higher saturation. The hue values also you have to change accordingly. Get back to my code, and so I will use the CV2 libraries. Okay, create track bar function once again, and here just like a variable name, I will just keep it as lower H value, like this, a low H value on this tracking window, which we have kept it as that particular name here. Okay, that same name I'm going to keep it over here, and its value I'm going to change it from 0 to 255. That is going to be the range which I'm going to put it over there, and it has to give see, we have just created this callback function called as nothing, and that is going to get called every single time when we change the value of the lower H value. So let me just copy this, and let's just create for the other five values as well. So let me come next line, and this will be the lower S value, this will be the lower V value, and just like that here we will be having the upper H value, upper S value, and one more for the upper V value. So let me just come here in that code. Okay, and here for the upper values, okay, let's set it to the maximum level, that is 25 comma 25 for all the three of them, like this. Okay, so we have a track bars. Okay, we'll be having six track bars which will set all these six values one by one, and those will be the values which will be applying on the mask or as a mask on that particular image. Now, your next job is to get the values where exactly these values have been set. Okay, these six values. So, those six values, what you can do is you can create as a variable names and you can store it. So, here, how you have created the lower b value and the higher b value. Okay, instead of lower b, you can simply name it as LB, and this one also you can keep it as H underscore B, or you can say it as upper boundaries as well. Okay, so let me just keep this as UB. Okay, upper blue and lower blue values. Okay, so that also, that value only I will change it over here as L underscore B, as well as this, let me change it to underscore B. Okay, now to get the values of all the six, okay, six values from the top. Okay, so let me say it as lower H value. Okay, lower H value you can get it by using cv2 dot get track bar position. Okay, and you will have to keep the same name which you have kept it here at the top, that is LH. Okay, so here that is the name, same value which you are keeping. Okay, and the window name which we have kept at the top. Okay, just like this. Okay, let me just copy paste this code and create the other five variables as well. Let me bring this to the next line, and I think one more, like this. So we have totally 6 points. Okay, so this is the lower S value. So let me just change this name, lower V value. Okay, and same way here also I'm change this to S and lower V value, like this. And for these values we'll have to change it to upper H value, upper S value, and here upper V values. So simultaneously here also, let's change those names appropriately. Upper H value, upper S value, and here upper V value, like this. Okay, and here, yeah, I think everything perfect now. Okay, so we have six track bars like this, and we have we are getting those six positions of those six track bars, which we have to apply as a mask on our particular image. Now, the final step for you guys to do is the values which you have given here, okay, the lower blue values, okay, these will be the lower h value for this one. So let me just remove that 110 and paste like this, and l underscore s will be the second value. So let me put it here in place of this 50, and here it will be the lower v value. So let me put it here, and just like that, upper h value will go here, upper s value will go there in the second position where we have written 255. So let's get rid of that, and the upper v value we just copied from here and put it here in this particular location. So this is the mask values which you are going to set from these six track bars, and we are going to get its position, and we are going to apply those as masks on our image. Okay, so now let's save the code and let's run the code. Okay, so it says one positional argument here is required and it is missing. So let me just rectify that error very quickly. So it basically says that this nothing function which we have created over here, okay, at the top requires one argument, but here I see the mistake what I have done. See, I was not supposed to write the parenthesis part of that. We just have to write the function's name. So that is the mistake we have done. So let me just get rid of those. Now let's save the program once again and let's run it. Okay, so it says tracking IVR create track bar. Okay, so it says so dot create track bar ls tracking zero nothing error we have got in this particular window. So let me just it says a null pointer exception, so which means it is not trying to point to this particular value which we have written over here in line number 10. So let me just go to this once again and let's check what the error is. And but before that, let's remove this and simply say it as pass. Okay, first now let me just run it once again. Okay, so we have, okay, now let's get rectify this particular error which we are getting as a null pointer exception. So let me get back to the code. Okay, so I see the mistake here. The window name we have kept it as tracking, and here we have done a spelling mistake. So let me just rectify that very quickly. So the C is missing, so that's why it was giving that error, and here also. Okay, here the spelling is correct. So let me just save it. Let's run the program once again. So as you can see, we have our mask window. Okay, we have our result window. Okay, this is the original frame, and this is the tracking frame, okay, which has all these hue values which we can set. So this is the lower hue value for h, s and v value. This is the upper values which is maximum, that is 255, 255 and 255. Okay, now what you can do is you can try to reset, okay, like this for any one particular color like this, and see right now I've almost set it to for the blue color. So here we are going to get the blue color like this. Okay, so let go a little bit like this, and see guys, like this we have set it for almost for the blue colors. Okay, and the higher maximum hue values also we can change accordingly based on the result we are trying to obtain. Okay, so these values only will give us a manual type of operations which we can perform to track any kind of objects. Okay, let's say we have to choose some different colors, then what I'll do is I'll just go with some other color by choosing a different version. This, let's see, we can get some red color values. Okay, let me go back here and like this. Okay, see guys, now I'm tracking all the red color balls from that particular image by applying this tracking mask on this particular frame. Okay, so this is how you can use track bars to do some manual operations on your particular image, and especially while object tracking. So let me just hit escape button and let's get rid of that particular code. Now let's say you want to capture or you want to track some object from a video file which you are capt- capturing from a live stream. Okay, so what you can do is can use your default camera to capture one image or video. So you can use this cv2 dot capture, sorry, video capture is the one, dot PID video capture, and you can pass a 0 as the parameter, which will start your default webcam of your particular system or your laptop. Then instead of reading this particular image, so let me just comment that one, and we can read that particular video. So the variable name we have kept for that video is called as capped, and you have to use the read function. Okay, and now the left side I'm going to keep the name that video file also as frame, and one more parameter I'll simply pass it as underscore. Okay, that will be the result value. I'm not going to use the result value, so I'm just keeping it as underscore. Okay, so this way what it will do is it will capture. Okay, so this line will capture the video by the default webcam, so that's why we are giving it as 0, and that is the frame. Okay, the video frame which we are capturing one by one, and that is what is passed over here, and these are the track bars which will work that particular image. And finally what we have to do, we have to release the image as well, okay, which we are capturing, and then we will destroy all the window. Okay, so this code is ready right now, and let me just run the code. Okay, and first what we will do is we'll set the values to track some kind of a blue color. So here I think the blue color, I think it was set to 110, somewhere near 110, and these values were something around 50 and 55 something. Okay, so these values were set when we were trying to identify the blue color balls from the image. Okay, so now this is the camera window, okay, frame which is getting shown to us. Okay, now all I have to do is I have to bring any object, okay, of blue color in front of that camera. So let me just bring something which has blue color in it. Okay, I have my tab over here, and let's move it in front of the camera. Okay, so I think we have not set the color that much properly, so let's try one more time to set those color values once again. Okay, so I guess this should do it, and let's try once again. Oh, so as you can see, it is tracking the blue color from that particular window. Okay, so this is how you set, okay, from a live stream, and you are tracking the blue color device which we are bringing in front of the camera. Okay, so this is an object tracking which you have done from a live stream video. So let me just get rid of the program by pressing the escape button, and it will go off. That's it. So coming to the next topic, okay, I want to talk about is threshold. So let me just close these files. Let me go to the project, and we have an image called as a gradient or something. So let's go to that image. So first let me just show you that particular image. So this is that particular image which we'll be using for the next concept, that is called as threshold. A threshold is a technique where you can remove the part of the image from its background. So first let's write the code for that. So let me just go to this uh, open the package, create a new file, say threshold. Okay, so .py extension it will put automatically. So first of all, let us import libraries, import cv2 as cv, then import numpy as n. So I'm going to read an image. So c dot im read is the function to read the image, and to show on the screen, I'm going to say c dot im show function, and we are going to say I'm showing this particular image window of this image, and then cv dot wait key for the unlimited period of time. So we'll put it as 0, then cv destroy all windows. So this is the basic code, okay, to read a file that is an image file and show that file on the particular screen. So let me just go to this view itself, because here we have the image location and everything. We can copy paste this whole line of code. Come up here, copy, and let's go to our threshold file and paste it over here, and just change the image name gradient dot png, like this. Okay, now let's simply run the code and let's show you that particular image. So this is that particular image in which the threshold concept will be used today. Now first let's the bottom, move bottom left. Okay, so let's come here so that it will be like this. Okay, code properly. Okay, now thresholding is nothing but comparing pixels of your image to a predefined threshold value, that particular image which we are going to set. Okay, so what I'll do is just after reading your image, okay, and we'll read that in black and white. So let's say give it as 0. Okay, that will be the second parameter which we are going to pass. Okay, now let's create the two variables. So one will be the underscore, that will be the result, so I'm not going to use that. So simply the second variable I'm going to keep it as th1, that threshold level 1. Okay, so from cv2 library, I'm going to use the threshold function. Okay, so it is first argument is the source file. So img is the source file which we are going to take, and the lower threshold value I'm going to keep as 127, and the highest value will be obviously will be 255. Okay, then we have lots of threshold methods which we can use. So c dot, we have to say thresh. Okay, and these are all the methods which we are going to see one by one. Okay, so the first method is called as thresh underscore binary, and we'll display it on the screen like what this thresh one looks like. So here let me just pass this thresh one value, the h1 value, just like this, and let me just change this window name also to th1 or something like that. Okay, now let's display both of these by using the im show function. Now what is the threshold value and what is the actual frame? So as you can see, we have got our actual image. Okay, our actual image like this here. Okay, and as you can see, okay, the threshold value and the image, actual image, okay, we are comparing each and every pixel level to the lower value, that is 127. Okay, till 255. So it is able to make some kind of a difference that from this level, okay, from this level, okay, the threshold value starts, that is 127, and it goes all the way up to 255. So this is how you are going to be using threshold level for any one particular image which you are trying to use those values for, which you are trying to remove the background from. So what has happened is, from here, okay, this whole thing, okay, is gone, and we are able to see the white background on this particular image. Now just let me just get rid of these two windows. press the escape button and those will be gone. Okay, and just like this, let's find out what are the other threshold methods. So let me just copy this and let's make this as th2, and here we have binary underscore inv stands for inverse. Okay, it is the reverse of what this threshold binary gives us. Okay, and just like this, how we are showing it on the screen, let's show that threshold 2 value also on the screen. I'll name the window also as th2 itself. So now let's save the program and let's run the code. Okay, you'll be able to see totally 3 windows like this. Okay, see guys, this is threshold 1 which we got from the previous code. This is our original image which is getting red, and now this one and this threshold 2 window are the reverse of that. Okay, so threshold 1 is like this, the white color part is on the right side, that is the background of this image, and inverse is the reverse of that. So this time we are getting the background white color on the this window. This is the third window. So this is what our binary inverse function does. So let me just hit the escape button and we'll continue from here. So now check one more threshold function. So let me just copy this and paste it one more, and that function is called as just underscore trunk. So shortcut for truncate. So let me just name this as 3, and we will print that window also separately on the screen as th. Here also I'll change this to h3. Okay, but for this we'll do some minor changes in the threshold level. So let's set it this as 50, and threshold 2 let it be 200. Okay, and threshold 3 let it be 127 by comma 250. Okay, now let's save the code and let's run it once again. When I run this code, okay, I'm going to get this fourth window. Okay, that is this threshold 3 value. Okay, and let me just show you the code exactly what it is trying to do now. Okay, so this is the threshold 1, we have set it for 50, so we have only 50 here, and the background it has removed, and this is in reverse, that is for the inverse, and this is our original image. So pixels of this is going to get compared with this one. So now the threshold level, the lower level is 127. So what is happening is until here, okay, until this part, until 127, okay, all the pixel values are same. Okay, and then after this value 127, okay, it is going to keep all the pixel values at 127 itself. Okay, it is not going to remove any kind of background. So it's setting, okay, it is setting the lower value 127 pixels on the right side part of this. Okay, as soon as it's 127. So this is what your trunc, that is the truncate function, does in finding the threshold values of the images. Now let's get rid of the code and check out one more function. So that is called as threshold 20. So 0 function is there. Okay, and let's name this as threshold 4, and let's show that also on the screen. Just come here and put as th4, th4. Let's save it and let's run the code. Okay, now let me show you that threshold 4 window. Okay, now what it does is, okay, till the level of 127, okay, till the level of 127, okay, it's not going to do anything. But if the value becomes less than 27, oh sorry, 127, okay, it is going to put it as black. Okay, and as soon as the values are from 127 to 255, it is going to remain unchanged. So this is, so as you can see, this upper image and the bottom image, as you can see, we have, okay, almost the same color towards the right side, but as soon as it became less than 127, it has given the black color, that is all 000. Okay, so 0 is black color and 255 will be the white color. Okay, so this is how you can use this particular function, okay, if at all the value is less than 127. Okay, like that. So next function we want to talk about is, okay, that is called as inverse of this particular function that is called as threshold 0 underscore inverse. Okay, it's just the reverse of this particular thing. Okay, so let me just make this as threshold 5. Let's print it on the screen as well. So let me copy this and paste it over here. Let's call this window as 2th5 and the variable th5 will get it from here from the top. So now let me just run the code and let me just show you the threshold values. Okay, as you can see, what this is doing is, if at all the value is less than 127 or greater than 127, okay, it is going to keep the reverse value of what we got here exactly in ph4. What it has done is, if it is less than 127, it has put it as unchanged, and if it is greater than 127, it has put it as zeros. So this is exactly the reverse of what we have used in 0 function. Okay, so now let me hit escape button and exit the code. Now let's use this technique on any one of the images, and we'll see whether this technique of thresholding actually how well it works on other different type of images and whatnot. Okay, so here what we'll do is we'll take this particular image. Okay, and you have to note that on the right side it is like lightly luminant than on the left side. Okay, so we'll try to remove the top end part from the background part of this particular image using the threshold methods. So what I'll do, first of all, let me just go to the top and let me create a new file, say applying threshold. So now let me just get the code from my previous program and paste it in this location, and all these values are not required. I'll remove all of those things and I'll just use only one technique, that is the threshold binary on this particular image. So I will say sudoku dot png. So that is the image and I'm reading it in black and white, and I'm using the threshold technique as threshold underscore binary, and let's set the values for the lower end to be like 127 and 255. So here we have our image. Okay, this is the original image which we want to show on the screen, and just like this, using the cv dot im show function, I'm going to show the threshold value th1, that will be the window name in which I'm going to show th1 value. So we have two values, right? So now let's run the code. Okay, and as you can see, this is the original image and this is the threshold value. Okay, so as I was saying, see on the right side, the luminance of this particular image is better than the left side. Okay, so this technique, okay, threshold binary technique didn't work properly on the particular image. So that is the reason. Okay, we have another technique, okay, of threshold, which is called as adaptive thresholding, which we'll be using for different quality type of images. So whenever the simple threshold method is not working, then you can go for the adaptive threshold method. Okay, so let me just create a variable called as th2 for adaptive threshold. So let me say cv dot adaptive threshold values. So first is the argument is our image on which we are going to apply, and the second argument is going to be an integer value and non-zero integer value for the number of pixels. So we know the maximum value we can give is like 255, and the next argument will be the mean of all the surrounding areas of that particular values. So as you can see on the screen, it is saying adaptive method. Okay, so adaptive method is nothing but, okay, we just have to find the mean value of the surrounding area. That's it. So from the cv2 library, I'm going to use the first adaptive method from cv2, that is cv2 that adaptive threshold and the mean value of its surroundings. Okay, so this will be the value Okay, and here the C will be the constant which will be adding on later. Okay, and the next parameter is the same, the threshold type which we are going to use. So that will be the simple threshold binary version of that. And the next parameter is you have to decide on the block size, okay, of the surrounding areas. So let us simply give it as 11. And the next parameter is the C value. Okay, C value is just the constant which gets subtracted from the mean value. So I'll simply give it as 2. Okay, and then how we are showing this one. Okay, we'll show the threshold value as well of 2. So let me just name that window as th2 comma th. Okay, so we are going to see the 3 windows for that particular application. So let me just right click and run the program, and as you can see this threshold level 2 window which where we have used the adaptive threshold method. So this is the original image which we are seeing on the screen, and this is the simple binary threshold which we applied. And see guys, this is the new and improved version of that particular image where we are applying the adaptive threshold method on that particular image. Just a button and that program will vanish. And just like this mean value of all the surroundings, we have one more value, one more method you can say, okay, in adaptive thresholding. Okay, so let me just simply copy paste this entire whole thing once again, and let me make this as 3 variable. Okay, and that method is called as thresh, okay, sh underscore Gaussian C. Okay, so this is the second method. So just like that, let us see if this method gives us a better result than threshold 2 or not. So let me just name the window as th3, and here let's pass this variable th3 over here, and let's see the result. So let us run the application, and as you can see we have this threshold 3. Okay, and this is for threshold 2. Okay, threshold 3 looks much more brighter than this threshold 2 values. Okay, so these are the two adaptive threshold methods which you can use on any one particular image. So let me hit escape button and will vanish. So the next topic I want to talk about is how to use Matplotlib when we are working with opencv. So first, to install Matplotlib you will have to go to file, then you have to go to settings, and then from here you will see your project name, that is the project name, and then click on the project interpreter, and here you are going to find all the libraries. Since Matplotlib is not there, I'm going to click on the plus button, and from here search window, search for Matplotlib. So this is the library which we want. We'll click on that and click on install packages. So in a few moments it will install, and we'll get a green color bar over here saying that this library is successfully installed. Matplotlib installed successfully. Then you can close this window, you can click on OK, and then let's create a new file for that. Okay, so let's say matplot underscore open cv. Now what I'll do, first let us import cv2 library, then let's import matplotlib py plot is the function which I want from uh, like this as plt. Okay, then I want to read an image, so I'm going to use the c2.im read function to read one particular image, and let's do it as unchanged. I want to see all the values just like that, and then cv2.im show function will show that particular image on the screen, and this displaying window, I'll keep it as window 1 or something, or you can just name it as image itself. So on the left side let me keep it as image itself. So this is how you're going to read and show the image. And now using the plt.show function, okay, we are going to show the image which we have just read, and let's say um, not once again I just said im.show function to show our image. Okay, and at the last you'll have to say plt.show function. Okay, so I'm showing my original function, original image, okay, as well as the same image from using Matplotlib library. Okay, and now let us give the image a location. So let me just copy this from the previous program, paste it over here. Okay, and let's change this to the same lena.jpg image. So first, now let me save it and let's run the code once. Okay, hey guys, you'll be able to see two windows. Okay, this is from the CV2 library. Okay, so this is the image. Okay, and this is the figure one. It says this is showing from the Matplotlib library, which we are seeing on the screen. So we get two windows like this. Okay, one from CV2 and one from Matplotlib. Okay, and you might be wondering why this color is coming as a somewhat lightish blue color, and this is coming as the original color. And this is because Matplotlib or in computer, okay, the colors are red as blue, green, and red, BGR. Okay, and your original colors will be in the format of RGB colors, red, green, and blue. So if you want to see a RGB means you will have to convert this BGR values to RGB format while using Matplotlib. So let me just press the escape button. Okay, or I'll just close it off because I have not used the wait key, all those things. So let me first add that code. So cv2 dot wait key, and let's pass 0 inside that, and then cv2 dot destroy function. Okay, destroy all window. Okay, now what we have to do is once when you have read this particular image and you are showing it on the screen, I will convert. Okay, I'll convert the image. Okay, so to convert the image, we have cv color function, and in that inside that one we have to first pass the image of which we are trying to convert the color to. Then we have to use cv2 dot color in capital underscore. Okay, so now as you can see here, we have lots of functions like bgr to hsv, bgr to gray, like that. We have one function, okay, that is called as bgr to rgb. Okay, so let me just write it here, like bgr to RGB. So this is the function which I'm going to do. Okay, then after doing that, I'm going to show that image using Matplotlib libraries PLT library. So now let's run the code, and you will be able to see two images. Okay, both of them in RGB format. Okay, and the numbers which you are seeing on the left and right, okay, that represents the shape 512 by 512. From 0 it starts till 512 it ends, both height and width. So if you don't want to get this numbers, okay, then what you can do is you can use the back ticks. So let me just close these windows. Okay, x ticks and y ticks for the x and y axis. So let me just come up here and say plt dot x ticks. Okay, you will have to pass an empty string like this, which means we don't have any values for that. Okay, so plt dot y ticks also will do the trick for the y axis. That's it. Now let's save the code and let's run file once again. So this is the file we are showing from the cv2 library, and this is the file which we are showing from Matplotlib. So as you can see, the left side numbers are gone right now. So this is how you can use Matplotlib to read and show your particular images. Okay, so let's just close this one and let's continue. Now let's go back to this applying threshold file where we were displaying all these threshold types from the previous code. Okay, now I think here. Okay, so this is the file. Okay, here we were showing 5 threshold types, okay, functions, and here is where we were showing them one by one. Okay, now what I'll do is I'll use a same Matplotlib library. So I'm going to say import matplotlib.py plot as plt. Okay, so I have imported the file matplotlib library inside this particular file, and here, okay, I'll not show these things like this anymore. Okay, instead of this, I'm going to use the Matplotlib library, okay, to display all of them. So first, what I'll do, I'll create the names of all the titles. So here I will say one is the original one. Okay, that is our original image. Then here, let me just write it in full itself. Okay, then the binary one, which we are trying to show for the first method. Then next one is the binary inverse method. So inverse, write it like this. Third one is the prunc function. Then here is uh, two zero function. To let me put like this. So then the last one, let me say two zero underscore inverse like this. Okay, so here we have so these many titles, so which we will display one by one along with the images. Okay, so here let me create a list of all the images which we want to show as a list. So these are all the images, like img is the original image, threshold 1, threshold 2, threshold 3, that one. So let me just write it here. I am the original one. Okay, then th1 comma th3 4 comma th5. We have all the threshold levels, 5 threshold levels, and the original image which we want to show on the screen. Now all we have to do is we have to loop through each and every one of these images. Okay, so let me write it like this. For I in range, okay, from 0 to 6 is 5 I want, so I'll write it as 6. Okay, and then I'll say plt dot you make a subplots you make. Okay, subplots, here you will have to mention how many rows and how many columns you want. So since we have 6, so it is better to make 2 by 3. Okay, 2 rows and 3 columns like this. Okay, and then I'm going to use the plt dot im show function to show each and every images. Okay, images of this I value. Okay, this images I value is 1 2 3 4, and like this 5 values have, and all of them I need to show it in grayscale. So what I'll do, I'll come here and say show them in grayscale. So here let me put a separate argument as gray. Okay, and you will have to put it in a single quotes or either double quotes like this. Okay, right now what we have done is, and here one more thing I forgot. Okay, we want the index values as well, so I plus 1, let me give it like this. Okay, so this is the subplot. Okay, the comma here and plt dot image I'm showing in the grayscale, and let us show the title of all the plots by passing the titles of I variable. Okay, title 1, title 2, title 3, like this. It is going to print all the titles for us. And since I don't want the numbers on the x and y axis, so I'll use the x ticks empty like this, and plt dot y ticks also empty, just like this. Okay, so it's not going to show those things anymore. Okay, then finally you will have to come out of the loop and say plt dot show function is. Okay, this is how I'm going to show all of these file labels using matplotlib right now. Okay, so now let me just run the code threshold, and you will be able to see one big plot in which we will have 2 rows and 3 columns, one after each other. Okay, so these are all the titles, and we don't even have those x tick and y tick variables anymore. Okay, and here if you want, you can click on this save button to save that image in any location you want. Okay, and then you have this configure subplot button where you can say the left side, right side, height and width, all those things you can adjust like this. Okay, and the bottom, from the bottom, and this is from the right side. Okay, so these are all the things which you can hue from this particular library. Just this, and this is how you can use Matplotlib along with CV2 library when you're doing work on your images or videos. So the next topic I want to talk about is something called as a smoothing or blurring. So for that, let me just create a new file very quickly. So Python file, let me say smoothing underscore blurring, like this. So here, first of all, let me just go to any one previous program and just copy this whole code of importing the libraries and reading one particular image. And for this particular thing, what I'll do is I'll read an image. That one is opencv, the logo image. So let me just this, and we are done. Okay, so I'm going to use the for loop to show the image. So for that, first what I'll need to do is we'll have to import the matplotlib library as well. So let me .lib.py plot as plt. So that library is also installed, imported. Then I'll say I'll use for loop for I in range, let's say 1. Okay, because I have only like one image. Okay, so I'll say plt dot subplots. Okay, subplot is one which I want to use, and I want to say like I have only one row and one column. Okay, and index value I plus 1, and the next value I want to give here is like this. You just have to put a comma and say plt dot im show function is that to show the image, and I want to show the images, okay, which we are reading. Okay, images which we are reading uh, of all the index values of I. Okay, now what we need to do is, okay, I'm going to say images. I'm going to create this variable called as images, this one, and I'm going to make it as a list of all the channels of this particular image which we are reading. So this is how we are going to show the image. And at last, this image which I'm seeing, I want to show it in the grayscale, so I'm going to keep it as gray. Okay, so this is the technique which we'll be using. Okay, and here I made one small mistake, so one extra parenthesis I've added. Okay, next let's add some title to this particular plot. So plt dot title is the function to give the title. Okay, and here I want to keep multiple titles and all those things, so let me simply say give it as titles of each value of I. And now let's go here at the top and create those titles variable as well. And first title is image. Okay, first title will be this particular image which we are seeing on the screen. Okay, now why I'm writing here like this is because if again if we have many more titles means we can simply add it here, and that is already added in the plotting code, so we don't have to worry about that. So now if you want you can keep this in separate line as well, so that code is much better to read. Okay, and then finally plt dot xticks, I want to keep it as empty because I don't want any kind of numbers on the left side, okay, or on the y-axis, x-axis or y-axis. So I'll use the y-ticks as well and keep it as an empty string. So this is how we are going to plot. So finally, whenever we are using the matplotlib library, we are going to use the plt.show function at the last. So this is how we are going to read and we are going to see our particular image on the screen using matplotlib library. Okay, so first now whenever we are using matplotlib library, you have to understand that, okay, the colors will be in blue, green and red. Okay, and we if we want to see this particular image in RGB format means then we will have to convert it using cv2 dot cvt color. Okay, so this is the function in which you have to pass your image as the first parameter, and then cv2 dot, okay, we have to choose the color underscore, and here we have lots of options: bgr2 RGB, bgr2 hsv, all those things. So since I want it in the original colors, I will choose this one, that is blue, green, red scales into RGB format. Okay, so this is how we are going to change the color of our image from the blue, green, red to RGB and store it back in our image itself. So now, very quickly, let me just run this, okay, and show you that particular image. So this is the image on which we'll be working on. Okay, so let me just close this window. Let me just show you the entire code. Okay, so this is the one. So let me just save it. And I'm noticing one more thing, that the CV2 library got added two times, once as CV2 and once as CV. So what I'll do is I'll just keep it like only once is more than enough, and wherever CV is there, I just make it CV2. Okay, so it will make sense. Like, let's save it. Okay, so now for the operation of smoothing, or which you called as blurring. Okay, we have lots of filters in opencv. Okay, so few of them, okay, we'll see one by one. Okay, and the most common one used is called as homogeneous filter. So let me write it here: homogeneous filter. Okay, this is the most common one. So first we'll have an example of how this homogeneous filter will work on our image. Now, to apply this homogeneous filter, what you have to do is you have to create a matrix of all ones, and its size, you can choose like 5 by 5 matrix. So that will be our kernel. Okay, so let me just keep a variable name called as kernel itself, and using the ones and numpy's ones function, let's create a 5 by 5 matrix, okay, in which all the values will be 1. So np dot, okay, this will be the data type. So let me just keep it as a float 32-bit, like this, and all these values will, I'll divide it by 25, so that all the values are ranging from 1. So now this will be the kernel which gets applied when this homogeneous filter gets applied. So now the destination image, okay, destination image on which you have to apply this filter to, that you have to use by using CV2's filter method. And especially in filter method also, there is one method called as filter 2D method. Okay, so this we are going to apply on our image. So we have to pass the first argument as the image which we have, which we are seeing on the screen. So this is the image, and then next argument is going to be the depth. So I'm going to give it as -1. Okay, it will require all the alpha values. Okay, that will be the one. And the third argument is the filter itself, which we are trying to apply on that particular image. So we have named it as kernel, and we are going to paste it over here. Okay, now this one, what we'll do is we, for this filtered image or the smoothened image, we'll keep one name like this. We'll say like 2D filtered image or something like that. 2D convolution image like this. So this will be the heading of that particular destination image which we are going to get after smoothing. So let's add it in this list also, that dst is the destination, img is the original, and after smoothing we are going to get this dist image. So now to print it, we'll just have to increase the range from 1 to 2, and here also let's make it as 2, and the next values I'm going to give it is, that's it. Okay, I guess we don't have to do anything else because we have added two images and two titles. Okay, and we are going to get one row and two columns. So now let me save this and let me run the program. Okay, so as you can see, we have this particular image. Okay, we have this particular image. Let me just size like this. Okay, and as you can see here, we have at the corners, if you see, we have little bit of edges. Okay, and they are not that good edges. Okay, but if you see the image on the right side, it is slightly blurred, and the edges are really smooth over here. Okay, this is this is what we have got after applying the homogeneous filter on this particular image. So this is the original image, and this is a 2D convoluted image after performing the smoothness or blurring operation on that particular image. Let me just close this one. So now I want to show you there is one more function which is called as blur itself from CV2 library, which you can use on your particular image also. And let's see what difference we can see on our image if we use that particular function. So cv2 dot is a blur function, blur, and you have to apply the blur on your particular image, so that it will be the first argument over here. And what will be the kernel size which you are trying to apply? So let me just give the same kernel size, that is 5 comma 5 on the image. And then here let me just put it as this blur method. Okay, so that will be the title of that particular window which we are seeing on the screen. And here the variable name blur. So now let's increase the range over here, so that we can have one row and three columns and three different images. Okay, so one by using the kernel. Okay, that is the homogeneous filter. And then so this is the 2D convoluted image. Okay, and this will be by using the blur method to blur our images. Okay, so now let me just rerun the program, and you should be able to see three images. Okay, three images. So let me just maximize this window a little bit so that we can see the image properly. Okay, see guys, this is the image, original image. And we have this second image is the Gaussian filter image, a little bit smoothed and a little bit blurred, so that we get a nicer edge on this. And now by using the blur method, okay, see there is not a lot of difference, but still it looks much better than the 2D convoluted image as well. So this is how you can use either the Gaussian blur or the direct blur method itself. Okay, so now let me get rid of this window. Let me just close it. Now let's try this on some other image. Okay, so let me just get rid of this and just type open. Okay, logo white also is there. Okay, so let me just use that image and see what could be the result. So let me just save this one and let's rerun the program. Okay, so we have this image. Okay, so we have this image. Okay, so this is the original image. Okay, this is the original image. So as you can see, it has lots of rough edges and all whatnot. Okay, when we have applied the 2D convolution on that filter, okay, as you can see, the image is a little bit blurred. Okay, the edges are also a little bit finer. And here also we can see that the text okay, right now has a little bit of smoother edges than the original image. Okay, and the third image, the blurred method image. Okay, so that is a little more vibrant than the, okay, with all the edges still more smoothened and everything. But there is not much of a difference between the 2D filter and the blur method. Okay, so let's close this one. Now let me just change it back to the original image, which was like opencv1, opens opencv, this logo image. So let me save it and let's rerun it once again. So you'll be able to see this particular image. Okay, here the text is also in black color, so we are not getting to see that particular image. So let me go back and change it to that white image itself, so that we can at least see the OpenCV text at the bottom. Yes, and the ways how we have applied the blurring operation. So now the next method which I want to use for blurring is the blurring, Gaussian blur. So let me just simply create a variable called as g blur for Gaussian blur, and from CV2 library I'm going to use this GAU, Gaussian blur class. Okay, see guys, whenever you see this capital, okay, so assume it's a class and we are going to use the constructor of that particular class. So first argument will be the image on which we are going to apply the Gaussian curve, and then the kernel size will be 5,5, and the next value will be the sigma value in the x direction. That you can call it a sigma x value. For time being we'll keep it as 0, and this will be our new image. So let me just add that variable name over here, and here also let me just keep a title for that. Let's say Gaussian Blur, like this. Okay, now let's just increase the size to 4, and let's make 2 rows and 2 columns. So 2 rows and 2 columns like this, and we are going to print it on the screen. So now we'll be having like 4 images, 2 rows and 2 columns. So let me just bring it over here, and let's see the result. Okay, so this last image is the Gaussian blur image, and which looks much better than any 3 of these images. Okay, so 2D convoluted images is at the right top. Okay, this is the blur method image, and this is the Gaussian blur method, much more better than these two. Okay, so now let's try this on some other image and let's see the result. Okay, so let's remove this image name, and there is one image called as half tone something. So let's go and check that one. Go to, okay, we have this image. Let me just find that image quickly. So let me just here it is. Okay, so let's try on this particular image, that is halftone underscore Gaussian underscore blur dot jpg. So let me go up here and just change the name of the image to halftone Gaussian blur. Let's save it. So I guess I've done it in different file, I guess. Smoothing or blurring. Here, from here, and just type halftone blur image, like, okay, now let me save it, and let's run the code. Okay, so here we have this particular image. Let me just maximize the image bit, and as you can see, we have this original image, and after applying the 2D and the blur method, now the Gaussian blur method, okay, we have identified as much as possible from this particular image, okay, by applying the Gaussian blur. So let me just try on a different image as well. So we have a one called as Gaussian blur R. Okay, we have this two image. Okay, so now save it, and let's run the program once again on a different image, and let's see how it's going to happen. So do it once again. I don't know why it is not showing. Okay, it's saying at line number 6 I have made some kind of mistake. Okay, see color and all those things like that. Okay, so I got the error that here we have just added 2 times. So let me get rid of that, and let's save it and run the file once again. So right now we have this particular image. Let me just maximize the screen. So this is the original image on which we have applied the 2D as well as the blur method, and as well as the Gaussian blur method to remove the noise, or you can say smoothing or blurring of this particular image. Now let's try it on one more image and see how it comes. So I have one more image called as blur3.jpg. So I'm using that, this one. This is the original image. So let's apply Gaussian blur on that. Let me save it, and let's run it once again. So this is how your final result is going to look like. Okay, so this is the original image, and after applying 2D blur image and the Gaussian blur image, okay, can apply these filters to smoothen or as you can see, blurring of the image. So the next filter I want to talk about, okay, which is used for smoothing or removing noise, that is called as a median filter. Okay, so this is referred to as removing noise from something called as salt and pepper noise images. Okay, so here let me show you what exactly I mean by salt and pepper. So first of all, let me just show you those images quickly. What do I mean by salt and pepper? So here we have one image called as baby.jpg. As you can see, it has a lot of white and black color, these things. And one more, I think we should have one is called as water something. Okay, yeah, here it is. Okay, so as you can see, it has a lot of white and black color image. Okay, these are called as salt pepper images. Okay, and then one more I think I had was that Saturn.jpg. Okay, so here like these white dots and the black color images. So we have to remove, okay, we have to apply that filter, okay, that is median filter to remove the noise from these kind of images. So let's do that. So to apply that, first let's use that particular image from here and say, let's use that water image. Okay, water.jpg image is there. Okay, and from CV2 library. Okay, so first let me keep this name as median, and from CV2 library we are going to get this median blur function. Okay, so first parameter is obviously the image on which we want to apply, and the next parameter is the kernel. Okay, so kernel size, it is asking case size. So case size has to be odd here, okay, like 3, 5, all those things, but it should not be 1. So that we have to keep in mind. So in our case, we'll keep it as 5. So this is the new method which we are going to choose, and let's put it in our list so that we can display it on the screen. And here let's give one title also for that. So I'll say median blur. So while using median blur, okay, what is the uh, changes we are going to see on the screen? So first let me just very quickly increase the range of this 5, and then let's make a 2 by 3. Okay, 2 rows and 3 columns like that. Then let's save the program and let's run it once. Okay, so we will get a very good result by using the median blur option. So as you can see, this first image is the original image. Okay, and then 2D, then the blur method and the Gaussian blur and the median blur. Okay, so how beautiful we are getting by removing all the white dots and the black dots from the original image by using the median blur function. Okay, so this is how you have to use so this is only is called as the salt pepper method. So now let us use on the other image and let's see how it works. So let me just remove that water and let's use that baby.jpg image, and let's see what will be the result. So let me just uh, first let me show you the original image of that particular baby image. So baby.jpg is this original image. Okay, now after applying median filter, so let's run the code, and as you can see we have got like this. So let me just increase the screen size. Okay, and this from this original image to getting almost very good results using the median blur. Let me just close this one and let's move on to the next method of filtering. Now this method is called as a bilateral filter. So let me just create a variable like that, bilateral filter equal to, from CV2 I'm going to use that bilateral filter method, and we have to apply it on our image. So I'll pass img as our variable. Okay, and now the second argument will be the diameter of the each pixel, okay, from the neighboring pixel values. So for time being we can keep it as 9 like this. So now the third argument is the sigma color, and the fourth argument will be the sigma space. Okay, so we will have to choose a value for this one and this one. So let's choose something like this. So the color value we can choose it as 75, and space we can choose it as 75 itself. Okay, and now let's use this a variable name to print it on the screen. So let me just have it here, and we'll just name the same thing over here as the title as well in double quotes. Okay, so bilateral filter. So let me make this as 6, and 2 by 3 is more than enough, 2 rows and 6 columns. But here we have to note one thing is why we have to use this bilateral filter. First, let me use it on that same baby image itself. Okay, and let me just show you by running the code. So this will be the bilateral filter. Okay, since our image is in black and white, we are not able to see that much. Okay, so let me just close this one and let me just use a different image. Okay, let me say we'll use that same lena.jpg image. Now let's run the code. Let's run the code. So as you can see, we have these six filters applied on the same particular image, and this is the last bilateral filter which we have applied here. Okay, bilateral, okay, filter, what it does is it preserves the edges of that particular image. Okay, so sometimes what happens is in image processing we need to have those images very carefully. Okay, so that we have to preserve the edges of that particular image. Okay, here as you can see, the edges of this hat portion is much better than any of these five images. Okay, each and every edge has been filtered very carefully in this particular image. So we have to note that we have to use bilateral filter only when we have to preserve the edges of that particular image. So this part was all about applying smoothness or blurring operations on our particular images. Okay, now let's come to the next topic, which is called as image gradients and edge detection from the images. So for that, let me just write the initial code for reading an image and printing it on the screen. So let me get back to you. So here I have written down the initial code to read a image, that is messy.jpg, okay, using cv2 library, and we are reading it in grayscale. Okay, instead of this you could have easily given 0 or -1 as well. Okay, so I have named this title as the original, that will be the original image which we are reading here. Okay, and number of images which we have right now is only one, so I have kept it here as a list of elements, and I have used the Matplotlib library and looped through each and every image, that is till only one we have, so I have just given here as one. So from one row and one column we'll have to see only one particular image. So I am show function is going to show all the images from those indexes in grayscale one by one. That's it. So x6 and y6 we have kept it as empty, and plt.show is going to show the image to us on the screen. So let's just run the code, and we'll be seeing a grayscale image of this messy.jpg image. So now let's close this file, and now apply image gradients and edge detection. Okay, there are few functions which we are going to use from cv2 library, and that method, you can say, that method you can say is called as a Laplacian image gradient. So for that, first thing what I'll do is I'll just create a variable called as let's say we have kept it as lap. Okay, now what we have to do is we are going to use cv2 dot, there is a function called as Laplacian. Okay, so Laplacian. Okay, so now what we have to do is we have to, first argument will be the image on which we apply the Laplacian method. Okay, and the next argument is the data type, okay, of that particular image, and that will be there is a method called as cv2 underscore. Okay, so there is 8as 16as, all those things here. Okay, but the one which we are looking for is the 64-bit float, so 64f. So this is the function we're using, because this function allows the negative values of the pixels as well. Okay, so if it goes less than 0, so it will handle those kind of pixel values as well. Now the next step which I want to perform is, see, this Laplacian method could have given us the positive or the negative pixel. So what we have to do is we have to just get this value, okay, the absolute value of this particular variable, so that we are in the positive range itself. So we are going to use np dot absolute method, okay, and pass that variable over here. Okay, and what we need to do now is this whole value which we are going to get, just to output the value of that particular image properly, I'm going to convert it into unsigned integer value, which takes like 8 bits of memory, and this whole thing will be inside that functions like this. Okay, now this will be the new Laplacian method value, okay, which we are going to get reassigned like this. So earlier this was here, and now we have just created a new variable that will be the absolute value of 8-bit integer type of values. Okay, now let us print those things and plot it on the screen. And here let me make another variable in the list of titles called as Laplacian. And here let me just add one more variable called as lap, so that is the second image. And here let's make the range from 1 to 2, and we are going to have one row, okay, and this time two columns in our plotting. Now let's save this code and let's run the code. Okay, and now this is a beautiful getting shown to us, which has identified all the edges from this particular image, okay, by using the Laplacian method. So now let's get rid of this. So if you still need to improve your image, okay, the edge, then here we can give one more parameter, that is the kernel size. So let me just say, okay, size equal to, okay, so first let me just try it with 1, and let's rerun the program once again. Okay, so at 1 kernel size, okay, you're getting this kind of edge retention from the particular image. Now let's go back and change this kernel size 3 and rerun the code. Let's save it and let's rerun the code, and this is what we have got right now. Okay, it is much more blurred, and it is trying to find the edges of each and every part of this particular image, wherever it is trying to get any part of the image, that background image as well. And here we have lots of dots and everything. Now let's say we are increasing the kernel size to 5, and let's save it and let's rerun the program. Okay, and when the kernel size is 5, okay, you're going to get this as the image edges, okay, image edges retention from this particular image which you are seeing on the left side, because it has now tried to capture the edges of the background images as well, which it is getting here apart from the messy image also. Okay, so for this I guess kernel size 1 or 2 or 3 should be more than good enough to find the edge levels from that particular image. So let's rerun the code, and this should be good enough. So let's close this program. So now I want to talk about the other two methods, are the global values. Okay, one in x and one in y directions. So let me just uh, those two variables over here. Let me say sobl, and this is x direction, and sobl, that is in y direction. So we have two variables over here, and let's use cv2 dot. Okay, we have that sobl function. Okay, so first what we have to do, we have to pass our image inside that, and we have to define the data type of that. So data type will like how we had earlier mentioned cv2 dot cv underscore 64 float. Okay, I'm going to use the same thing just like this. Okay, and the next parameter is the x direction, for which we are going to give it as 1, and for y direction we are going to give it as 0, because it's we want only the x direction of that. Okay, and just like this only, let me just copy this whole thing and paste it over here once again. And only thing what you have to remove here is you have to make this x direction as 0, and you have to make this y direction as 1. Okay, so we have got two variables like this. Okay, now in case of Laplacian also, we had converted this into the absolute value. So just like that only, I'm going to convert this to as absolute values and override this variable name here on the left side. So let me just put it here. So this will be the new value of Sobel X values, and here let me just place that value like this. Okay, and the same thing goes for the Sobel Y value also. So let me just copy this and paste it over here, and let's change this to capital Y, and we are going to also do the absolute scale. Now the only thing left for us to do is plot the graphs, and let's see the result how it comes for Sobel X value. Correct that spelling. and one more for the global y value. And here let me just go and add those two variables, global x and global y value. Now we'll be having the range from 1 to 4, and here can make into two rows and two columns like this. So let's save it and let's rerun the code. So as you are seeing on the screen, we have got this beautiful image. Okay, so this is the original image. So this is while using a Laplacian to find the edges, and this is the Sobel x direction. Okay, Sobel x direction. As you can see, we have got these layers of these layers of edges in this direction, and for Sobel y we have got the layers on the horizontal direction. Okay, so this is how you can find the edges. Okay, you can find the edges, or you can say you can retain the edges from your particular image depending upon the kernel size and all those things. So first let me just do one more thing at the last. Let me just change the kernel size to, let's say, 1, and let's rerun the program once again. Okay, so this is going to be the image, and as you can see here with Sobel X, okay, we can see more towards the face and the background images like this. Okay, and with the Sobel Y direction, we can see background image is much more brighter. Even the messy image, the edge retention is much more better. Okay, so it depends upon whether you want to find it in the X direction or the Y direction. Okay, you have these three methods. One is the Laplacian, one is the Sobel X, and the Sobel Y methods. So this is a very useful trick while doing image processing. Now let's try the same code on some other different image. So let me just get rid of this. We have one image called as sudoku.png image. Let's save it and let's run the code. So let's run the code once again and get this particular image. Okay, and it is not that clear to us. So let's do one thing. Let's increase the kernel size. Let's run the code once again. So this time, okay, you are going to get a much clearer picture than. So this is the original image, Laplacian result. Okay, this is the Sobel X where we are getting this kind of gradient and the edges towards the vertical way, and here in Sobel Y we are going to get towards the horizontal way. It's horizontal edges we are going to get. Okay, so that's why we are horizontal lines over here in this particular image. So like this, whenever you have to find the edges and we have to retain the edges, we are going to go with these three functions or methods which we can use. So now let me just close this file. Now let me just show you a very cool trick. If you want to combine these two values on one method itself, okay, you can use the bitwise operator, and let's say Sobel combined or something like this, and we can use the CV dot bitwise and operator is there, and or operator is also there. Okay, so I'm going to use the or operator because it can be either the Sobel X or the Sobel Y. So we'll just have to pass these two variables inside that, and let's come over here and let's copy this one once again and paste it over here as well. Okay, now this will be the fifth image. So let me just copy the name here and put it as the titles in double quotes, and as well as the image, that is the combined image, but with without any single quotes or double quotes over here, because that is going to be the name. And this time let's say we have two rows and three columns, because I have the fifth image, right? So here as 3. Let's save the code and let's run the code, and this time you'll be able to see okay, we didn't get the combined image. Okay, because this is what we have done over here, because here the range I forgot to change the range 5. So let me just rerun the program once again, and you should be able to see the fifth image. Okay, and that is the combined Sobel values on this one. Okay, so it has combined the Sobel X and Sobel Y image, and it has given us the proper edges retention from this particular original image by using Sobel X and Sobel Y values combined together on that particular image. Now let me just close this file. Okay, and so this is one of the methods. Okay, these are the three methods which we just saw. And now, apart from these three methods, okay, we have one more method that is called as canny edge detection. Okay, it is much more better than these. And so for that, what I'll do is I'll just comment off this code. Okay, and let's use that messy image once again. Messy image.jpg. So let me get to the PNG from the last. Okay, and now let me apply only that canny edge detection. So let me simply say it as canny equal to cv2 dot. Okay, there is a class called as canny, so I'm going to canny. Okay, first is the image which we have to give, and now we have to give the lower threshold and the upper threshold values to detect the edges. So I'm going to say the lower threshold value to detect the edge should be 100, and the next value, the upper threshold value, let it be as 200. Okay, so we have our canny edge detection values, and here uh, okay, since I had kept these two variables, just take this. Okay, let me take these two values itself here as title is equal to, and here let me see as first one will be the image, original image, and the second one will be the canny image. Okay, canny image. So like that. And total images which we are supposed to show is first of all the original image, that is the img value, and the next one will be the canny one. So let me grab this and put it up before the assignment, like, okay, and here let me write that name, canny. Okay, now all we have to do is range from 2, and here 1, and column should be more than enough, and let's see the result now. Okay, so we are reading this black and white, that is my, and let's run the code. Okay, so while using the canny technique, okay, so as you can see we have got a very nice okay, edge detection of each and every particular frame it has got from that particular image. Okay, so this is a very highly effective way of doing the edge detection part. Okay, so that's why it's named as canny edge detection using opencv. So let's do one more thing, and let's try it on a different image, and let's check the result for the canny image. So we have that lena.jpg there. So let's try it on that, save it, and let's run the code, right? Okay, so you'll be able to see there is a the edge retention is much more better than any of the methods which we have used so far. So let me just close this very quickly. So let's get rid of these variables, and we'll just add it to the whole group itself. So this is a global method, and after the global method we are going to use the canny method like this, and I am going to uncomment this, and let's uncomment the previous code as well, and here let's add this as the sixth title, that is the canny edge detection. So this will be the sixth one, and this variable canny, I'm going to add it here in the list of images which we are supposed to show, and this time we have 6 images. So here the range will be from 6, and here I want to make 2 rows and 3 columns, so 2 3 6 images will get see on the screen. Okay, for all the edge detection or edge retention. Okay, so let me just open all 6 images. Okay, so as you can see we have a very good edge retention in the canny edge detection method. Okay, so now let's close this file. So the next topic I want to talk about is something called as image pyramids. So let me just write a sample code for that and get back to you. So here I have written down sample code just to read this learner.jpg image and show it on the screen by using the CV2 library itself. So let's run the code and show that image to you right now. So this is the original image and in original size. Okay, so first of all, let me show you what exactly this pyramid means. Okay, so two types of pyramids you can make. One is Gaussian pyramid and one is a Laplacian pyramid. Okay, and there are like two functions. One is like pyramid down and pyramid up. So pyr down and pyr up. So let me just show you what pyramid actually means. Okay guys, here we have an image that level 0 is the original image, and if we want to have a uh, half resolution of that, okay, the smaller size, and it will decrease the resolution as well, and it will decrease the image size by half of whatever the original length is. So this is like a pyramid up scheme. Okay, so then again, if I go one level, okay, more than this resolution one, okay, it is going to be one fourth of this original image, and then it can keep on going one levels like this. So this is what is called as pyramid up and pyramid down. Okay, so like this. Okay, and pyramid down, and these two functions are available, okay, for the Gaussian pyramid schemes. So first, let us do let us decrease okay, let us decrease the resolution of the images. Okay, so you can choose any level you want. Okay, so first let me just come here and write a code like this. Okay, so simply let me say like this: level 1. Okay, level 1 is equal to cv2 dot pyramid pyr. Okay, let me use that down function down. Okay, and so for this image we have to come one level down, and we are going to show that also on the screen by using this cv2 show function. So let me just put it here like this, and here let me just name it as level 1, and here let me pass that variable name level 1 like this. Okay, now just get rid of this backward slash from here. Let me save the program and let's run the code like this. Okay, so you'll be able to see two images. Okay, so you'll be able to see the two images. uh let me uh, let me come here. So this is the original image, and along with this we were supposed to show one more. uh, I don't know why that is not getting shown. Let me back. Let me hit a escape button, close the code. Let me try one more time. Let me save the program once, and let me rerun the code. So here, okay, so here we have two images. Okay, and if I put just one above the other, as you can see, it is now become, okay, the first level has been dropped down to this resolution. Okay, now just like this we can have one more level of reducing down. Okay, so first let me just hit escape button, and this code, okay, this code, let me just simply copy and paste it over here and say this is at level 2, and the image which we have to pass here is the level 1 image. Okay, and that level 1 image also along with the level 2 image, show it on the screen just by using the same cv2 functions like this, and let's just name it as level 2, and here this one will be level 2 like this. Okay, now let me just save this program and let's rerun the code. Okay, so this time we should be able to see, okay, three images on the screen. So we have our one image, two image. Okay, this is the level 1 image, 2 image, and the last, the third image. Let me just uh, bring it on this particular screen. Yeah, there it is. Okay, so right now, as you are seeing on the screen, so we have three images. Okay, one, two, and three. Okay, so this is the third level, or this is the second level. This is the original image, this is the level one, and this is the level two image which we are seeing on the screen, just like this. Okay, so let me just hit a button and we will close the program here itself. So this is what is called as pyramid down. Same way, what we can do is we can use the pyramid up function. So let me come here and say um, higher resolutions. So I'll simply say it as HR resolution 2. Okay, just like this. And let me use the CB2 library. So let's say pyramid PYR up. So let me use that function and let's pass the level 2. Okay, the smallest image inside that one, and let's print that also. So let me just copy this line, paste it over here, and say this one as pyramid up 1. Okay, something like this. So let me keep something like this, and the name here we have taken it as HR2. Okay, and let's save it and let's rerun the code. Okay, so as you can see, we have these three pyramid down images. Okay, and just move this like this. Okay, and now let me bring that pyramid up image something like this. Okay, so this is at a higher resolution of this particular the smaller image, but as you can see, when we move up the scale, okay, we are going to lose a lot of color intensity, the edges and all those things from that particular image. So let me just close this program. So we can also do this layer by layer operations by using a for loop. So for that, what I'll do is I'll just copy this code and paste it here at the bottom. So one more time. So let me just comment off the previous code like this. Okay, and here, so here it's like a new program right now. And what I'll do right now is first let me get rid of this output window. So here we are reading one image. So that is the linear.jpg, and this time what I'll do is I'll create a variable called as layers, and I will use the copy function. So instead of using two layers variables like this, I'm going to have only one layer. Okay, and from that image we are going to copy the image to this particular variable name, that is the layer. And this time what I'll do is I'll say simply keep a variable called as Gaussian pyramid layer GP, and I'll use a list of the layer which we are going to get from this particular image. So like this. Okay, and instead of using so many times I'm show functions, so let me just remove off all the previous code like this. So what we will do is we will write a for loop to print each and every layer by doing a pyramid down function. So what I'll do for I in range, let's say we want 5 levels. Okay, we want 5 levels. Then we'll say layer is equal to, from CV2 library you have to use that pyramid down function, and you will have to pass your layer which you are, the image layer which you are getting copied over here like this. Okay, and once it is done, we are going to perform a we are going to build that Gaussian pyramid by using the append function of those particular layers which we are going to get right here in this first line of the for loop. And then what we have to do is we have to show it on the screen. So cv2 dot image show function will use I'll use the str of I function to print all the layer numbers, and then we will use the layers which we are getting from the like this. Okay, so we got all the 5 layers just like this. Okay, and at the last, okay, at the last I'm going to show the original image as well. So I'm so going to say image dot show, and we'll keep a name for that window. I'll name it as original image, and then we'll have to pass the original image variable which we are seeing here on the screen. So now let's save the code and let's create our pyramid in this particular manner. So let me just bring all the layers. Okay, so this is 0 layer. Okay, as you can see, there is a number on that. Okay, that is why we had used the str function. And then let me bring the other values also. So this is okay. So let me just, so here we have 1 2 3 4 5. Okay, so like this, we are going to get, so here is 0. So let me bring value also. So this number you can see it's 3. And so like this, okay, we are going to get 5 images of this on the screen. I'm having a really hard time uh, making this come to one single screen. Okay, but you get the point. So now this is how you're going to build a pyramid using the Gaussian pyramid functions, that is pyr down function. So this is going to be the end of the second part of learning opencv in Windows. Thank you very much for watching this video. Okay, I hope you liked it. Please like and comment my channel.